Hello everyone, welcome to Mr. Schultz's class as we begin to solve equations by graphing. Make sure you write your name and period at the top of your paper. Graphing. So, the inquiry question we have today is, how can we solve a polynomial equation by using the graph of a related polynomial function? Well, what values of x would make this statement true? So we're actually going to graph this, but we're going to notice that, hey, there's no y, so it's only going to have an x value. So we can start plugging in numbers like, hey, if we plugged in 0, would it work? No, it's not going to work. So if I plugged in 0, 0, 0, 0 is equal to 0 plus 6. No, that's not true. But if we plugged in negative 1, negative 1 times negative 1 times negative 1, I got negative 1, and then plus 2 plus 4 is equal to negative 1 plus 6. Well, I have 6 plus negative 1. Hey, wait a second here. 5 equals 5, so negative 1 works. And if I actually put in all these numbers, I could plug in like negative, see if negative 0.5, negative, let's see if that works. If I plugged in these numbers, I would eventually realize that negative 3, negative 1, and 2 are the solutions. They make this a true statement. Now, I could try to solve it, and I'd be like, plug and chug, but there's an infinite amount of numbers I could plug in. I could plug in 2, I could plug in 2.5, but like, I won't know what the answers are. And that's why, hey, we're going to use technology. So the first thing we're going to do is we're going to move everything to the other side. So I'm going to move this x to the other side. I'm going to minus x on both sides. So I'm left with x cubed plus 2x squared minus 4x is equal to, go back, minus x is equal to, hey, wait a second, I want to move this 6 too, so I'm going to minus 6 on both sides. Minus 6 is equal to the function of x. And now I'm going to say, hey, we also know that that's our y value, or the height. And so if we make this true, we're going to figure out, hey, what happens? Where do we hit 0? What are our roots? What are our solutions? So if I plug this in, and bear with me as I go to my other tab, if I plug this in, I get this right here. And I can zoom in, I can see, hey, look, here are my answers right here. Negative 3, negative 1, and 2. Let's put it right there. Make it a little bit smaller. Here we go. So my roots are my solutions to this. Negative 3, negative 1, and 2. So I can create my function, a new or relative function, a related function, and it will tell me what would make this statement true just by graphing it. Let's do the next one. So we're going to create a related function by having f of x on one side. And then we have to make it equal to 0 because we're figuring out when does it hit the ground. So here's our example. Example 1. What we have to do is move everything to one side and then make it equal to f of x. So f of x is equal to x to the 4th plus 4x cubed plus 3x squared minus 5. I want you to graph it. So I'm going to pause it. I'm going to have you do it. Here we go. So if I do graph it on Desmos, I'm going to see this. So if I go back, I should draw it in. Now this is a horrible looking drawing. I could have just copied and pasted. But I can figure out where does it hit the zeros just by going back and clicking. I have it at negative 3, and 0.841. So if I'm using technology, I can literally just copy and paste, come back over, and paste it right there. So here we go. What are the solutions? I have the solutions for this one. The roots are negative 3.22 and 0.84. I'm going to round to the nearest hundredth right here, guys. And I'm going to tell you right now, there's no way I would have been able to guess this without using the technology. Let's go on. So, classwork. I want you to do the following. Plug these numbers into the calculator and figure out what does it look like, and then tell me what are the solutions to each of the graphs, to each of the equations. What are the roots? Where do they hit the x-axis? And before we go on, I want you to tell me the following. Tell me 2 questions that you have about this activity. All right, guys. Thank you very much. I hope you have a wonderful day. Bye.